Well, hello there! Today we're going to be looking at computations and the different strategies we use to solve equations. The equation for today is 13 times 27. But before we solve the equation, we need to estimate. An estimation will give us a clear idea of where our answer should be. When estimating, we need to turn these two factors into a different number. Some say we turn these into friendly numbers, numbers that we can use easily. For the number 13, the number that strikes me right away is number 10. 10 is a nice easy number that we can use in our estimation. 27 is a little trickier though. I could go down to 25, or I could go up to 30. However, I'll use 30 because I already decreased 13 to 10. And if I decrease both numbers, I'll get an estimate that's too low. Now I have the equation 10 times 30. I know that this number is going to be 300. I know this because I'm looking at the zeros. All I'm doing is just adding two place values to my number. I'm going to store the number 300 in my head. This will later tell me if my answer is reasonable. To solve the equation, we're going to be using manipulatives. That's right. Base 10 blocks! The area model helps me by seeing the different ways I can break down the equation. Right here I have what seems like a big rectangle, but actually it's a bunch of small rectangles. I have my equation here 27 times 13. Here I can then break down 13 into 10 and into 3. 27 I then break down into 20 and to 7. Now I have little areas of rectangles. Right here is a rectangle, right here is a rectangle, and right here is a rectangle. I can then multiply and then add all these small rectangles up. The first area that I'm going to look at is this one right here with the two flats. This can also be known as 20 times 10, but I can know this as two flats, which is 200. My next area is this rectangle right here. I know this has 7 rods, but this can also be thought as 7 times 10. This is 70. My third area is 6 rods, but this is also 20 times 3, which is 60. This area, I don't want to count individually each unit. So I'll just look at 7 times 3 as being 21 units right here. Now that I have my measurements, I can turn this into a simple addition problem. But I'm going to make it even simpler for me, and I'm going to change 70 and 60 into 130. I know this because 7 plus 6 is 13, and I just add a 0 for the place value. I then add my 200 and my 21 to make 351. I'm now going to demonstrate another strategy to find the product between the two factors 13 and 27. This strategy is called partitioning. I've deconstructed the numbers to make them easier to work with. But I get to the number 7 times 10 and 7 times 3. Now admittedly, this should be 7 times 13. But I've made them easier to work with by deconstructing them further. I can add these numbers up, or I can make it easier. I see that 70 and 130 will actually make 200. I can now add these numbers up more easily. This gives me my total of 351. And it's that simple. But wait, what about my estimation? 300 and the answer was 351. Well, I was 51 off. But you know what? That seems reasonable to me.